Welcome to session number 2 of the Strimzi Con this year. I'm going to talk a little bit more about more kind of day 2 operations, particularly around how you manage large fleets of Kafka clusters with Strimzi and how you manage upgrades around that. As Paolo said, I'm a senior engineer here at Red Hat. I've worked on Strimzi for quite a few years. So I'm going to go over Strimzi upgrades as they are right now when you install Strimzi as normal. And some of the things you need to watch out for when you do that, particularly when you have large numbers of Kafka clusters on your Kubernetes cluster. And then talk a bit about how we could upgrade things better in a kind of phased, more controlled way. And then I'm going to go through a kind of an example way to do that, how you could set that up and go through some of the things you need to watch out if you're going to do this, and then go through a phased upgrade process to show how that all fits together. Now, some of you may have read the abstract for this post, for this talk, and thought that should have been a blog post. And the good news is that it is. So back in April, I published quite a detailed blog post that steps through each of these phases, discusses things in detail, gives examples and how to set things up. There's also a code repository with all the example code in. So you can go there and try this out for yourself on your own Kubernetes cluster. And hopefully that'll have all the answers you need. Hopefully there's going to be time for Q&A at the end of this session. But as Paolo says, the Q&A box, the chat is there. And I'm on the upstream Slack. I'm quite active up there in the CNCF Slack. So do ping me on that if you have any questions that didn't get answered in this session. So Strimzi upgrades. So some of you may be familiar with what a Strimzi installation actually looks like. Many of you might use the Helm chart or Operator Lifecycle Manager, and that's just an installation. But if you look at the actual install files in Strimzi, there is the deployment itself, which deploys the Kafka, the cluster operator pods. But there's also there's lots of other stuff that comes with it. There's the CRDs, the custom resource definitions, and these are the things that tell Kubernetes about the Kafka resources, the Kafka Connect resources, the bridge, Mirror Maker tells it how to interpret those. And each version of Strimzi has a version of those CRDs. And then there's a bunch of other configuration and RBAC stuff that comes with Strimzi, some of it cluster scoped, some of it namespace scoped. But I'm going to keep this a fairly high level conversation. So we're just going to talk about CRDs and the deployment. So when you've got your cluster up and running, you've got Strimzi looking at lots of different namespaces. It's monitoring all of the Kafka deployments on your Kubernetes cluster. When you upgrade Strimzi, what you'll do usually is you will upgrade the CRDs and the RBAC and other systems, and then you will upgrade the deployment. Now, at this stage, you've not touched your Kafka CRs. They're on the same version. You haven't touched the CRs. You haven't edited them at all. But what will catch out a lot of new Strimzi users is at this point, all of your Kafka clusters will roll. So this is your Kafka clusters. This is your Kafka Connect. This is anything that Strimzi is managing will roll at this point. Now, the reason it does that is because of the deployment. So inside the deployment that defines how the Strimzi cluster operator is set up, there is these environment variables that define and map between Kafka versions and an image version. So as you can see here, each of the supported versions of Strimzi defines an image. Now, when you move to a new version of Strimzi, the image changes because the Strimzi version is inside those images. So even if you haven't touched anything and you're still pointing to Kafka 3.7.1, for example, under the hood, Strimzi is going to reconcile your CR. It's going to remap that image. Something's changed, so it needs to roll the cluster. So the reason that the Strimzi version is in those images is because the pods themselves actually present a kind of API. So inside the containers that run your Kafka systems, Strimzi places health endpoints, environment variables, configurations, and scripts that it expects to be there. And new versions of Strimzi might change those things. They might add new things in. And so if you were to run a new version of Strimzi and not change the image version, then the new version of Strimzi might go and ask for an endpoint that it expects to be there, and it's not there. So this is also a very important reason as to why if you build your own Strimzi images, if you layer in new plugins or you add additional stuff in yourself, you need to make sure when you're upgrading, if you're overriding that image, that you're keeping your base image up to date with the version of Strimzi you're running. So that's why when you change the deployment, even though you haven't changed anything else, you're going to roll all of your Kafka infrastructure. Now, if you've only got a couple of Kafka brokers on your Kubernetes cluster, maybe this isn't too much of a concern. But once you start to get very large numbers of Kafka clusters, the effect of this multiplies. So Strimzi will maintain Kafka topic partition availability, provided your replication factor is above 1, which it absolutely should be. Provided that, Strimzi will roll one broker at a time. It'll maintain that availability. So there won't be any loss of that availability of your data. But of course, producer applications are going to send to a leader that might be rolling. So they have to get new metadata. They'll fetch that new metadata. Consumers are the same. So there will be a little bit of churn. There'll be a little bit disruption. But in an ideal world, hopefully it'll be minimal. But of course, we don't live in an ideal world. I've experienced lots of client applications that experience a metadata refetch and just fall over and crash. And there can be configuration changes. Maybe you've customized the configuration for this new version and things have rolled out everywhere all at once. And the big concern here is that you're going to end up with your infrastructure team. Anybody who's going to have a problem, they're all going to happen at once, which is obviously not a great idea. So what we would like to do is to have a more phased upgrade approach. I'd like to roll my lowest risk dev clusters first, check maybe I've got a canary that my infrastructure team runs. I want to run that first before anything else happens. I want everything else to stay as it was. And then as we move up the risk kind of budget, we kind of go, right, well, we need to make sure that we're rolling these things. And then when we get to production, we're fairly confident things have happened in the right order and everything's okay, so we can roll on. And it would also be good that if we do encounter a problem at some point, that we can easily just go back. So as you can see, if we've just installed Strimzi and we've rolled the whole thing, under the default setup, if you need to go back once you've got to production, you've got to take the Strimzi operator back, and then you have to roll everything again. So obviously, this is not something when you've got a lot of Kafka clusters that you want to be doing. So what we'd like to have is this phased upgrade approach. So there are different ways we could do this with what Strimzi gives us right now. And one option I've seen out there and seen people suggest is to use Strimzi's pause annotation, pause reconciliation annotation. So what this does is you apply this to a CR and it tells Strimzi to just ignore it. So what you could do is before you do your upgrade, you could annotate all of your Kafka CRs, your Kafka connects, everything with a pause annotation. And then when you do your upgrade, the new Strimzi deployment will come up. It'll try and the image has changed, but because it's told to ignore everything, it won't do anything. So everything's running. And then in order to do your phased upgrade, you just remove your pause annotations. So as you move up the system. Now, the problem here, well, there's two key problems with this setup. One is what happens when something goes wrong. So if something goes wrong when you've reached your production level, what you have to do now is you have to pause everything again, downgrade Strimzi, and then unpause everything to get it back into the correct format. The other bigger problem is that for the whole period where you're waiting for something to be upgraded, it's completely unmanaged. You've paused reconciliation. You can't make any changes, any admin changes. You can't update certificates. You can't fix configurations. So obviously, this setup might work if you've got a very small number of Kafka clusters and you've only got one or two that will only be paused for a short while. But once you've got a large number, this doesn't really scale very well. Another option is to just have a Strimzi deployment per namespace. The extreme version of this is to just have one Kafka cluster per Kubernetes cluster, but that's quite extreme and quite wasteful. But you could install namespace scoped Strimzi operators per namespace. And then when you upgrade your CRDs and RBAC, you just upgrade one deployment at a time, and that will roll every Kafka cluster inside that namespace that Strimzi is looking at. So again, for a very small number of Kafka clusters, this might work. But once you start to scale, it becomes quite wasteful from a resource perspective because Strimzi deployments are perfectly capable of managing hundreds, tens to hundreds of Kafka brokers without much of a problem. So you're wasting resource there. But also, as you go up, you could, in the worst case, be mapping one Strimzi deployment per Kafka cluster, and you've got to manage all of their config, and it becomes a bit of an operations nightmare after a while. So, unsurprisingly, I do have a better option. And if you take away nothing else from this talk, I want it to be that you realize that this option exists. And this is taken verbatim from the docs. This is the Strimzi custom resource selector. And what this is an environment variable inside the Kafka cluster operator deployment settings. And what it is when it's present, Strimzi will look for the label you define in that environment variable. And if a CR has that label, it will reconcile it. If it doesn't, it'll ignore it. So it's quite a powerful tool that allows you to isolate CRs between particular deployments of Strimzi. So why is that useful? Well, now what you can do is if you can deploy two cluster scoped Strimzi operators looking at different resource selectors, you can specify the selector on individual Kafka CRs, and they will run in parallel, and they will be managed independently. And what that means is when you upgrade your CRDs, you upgrade one of the Strimzi operators, only those that are managed by that particular operator installation will roll. And if something goes wrong, rollback is incredibly simple. You just change the label to point at the old operator. It'll go and update the images, and it'll go back to its old working configuration. So that's quite a powerful tool, and this is a setup that I think is much better than the two that came previously. Now, it's not this straightforward, as you can probably tell, because we're only halfway through this talk. So there's quite a few things that you need to bear in mind if you're going to implement a system like this. So the first one is that if we look at this layout here, we can only have one set of CRDs. So because CRDs are cluster scoped. So if you're going to install multiple versions of Strimzi, you can only have one set of the CRDs. Now, the CRDs are backwards compatible, which means older versions of Strimzi can run with newer versions of the CRDs. And they have to be like that because we test them during upgrade. Because at some point in your upgrade process, you will have newer CRDs and an older Strimzi potentially. So we test that scenario. They are, however, not forwards compatible. So you can't have an older version of the CRDs with a newer version of Strimzi. Right, and because the new version of Strimzi might be expecting some field that doesn't exist in the old CRDs, and so you could encounter problems. So what that implies is that you have one set of CRDs, and they have to match the most recent version of Strimzi that you have installed. Also, as I mentioned before with testing, the compatibility between Strimzi versions and CRDs is only in adjacent versions. Right, so that's the only tested setup. That's the only setup we know works. You could install Strimzi, have older versions several back with newer versions of CRDs, but they're not tested and your mileage may vary. So we only really recommend that you have two adjacent versions. And there's a particular case that I'll go into in a bit detail later, which is where the CRD, the Kubernetes API versions of these CRDs change. So you have to handle that in a special way. But with that CRD caveat out of the way, what we still need to do is we need to have two versions of Strimzi deployed simultaneously in our Kubernetes cluster. So once we've sorted out the CRDs that match the most recent version of Strimzi, we also need to isolate all of those other resources that come with each Strimzi installation. Now that's important because your RBAC might change between versions, right? A new version of Strimzi might have different permissions to an older version of Strimzi. And actually, because you want to keep your permission surface as low as possible, it's perfectly possible that a new version of Strimzi might take away some permissions it no longer needs, but the old one still needs to run. So you don't want the old Strimzi pointing to RBAC setups from new Strimzis, and it can get messy. So basically, we want to isolate those two setups as much as possible in the installation files. And we need each Strimzi to have its own custom resource selector so that we can specify the labels. So we've got kind of a requirement set there. And what we're really talking about is taking the upstream installation files and resources and altering them a bit, changing them and putting some templating in there so we can meet those requirements. There are lots of tools out there for doing those kinds of things. A lot of you, I'm sure, will be installing Strimzi through the Helm charts that we've got. We've also got the Red Hat's operator lifecycle management that comes with OpenShift, way of deploying those things. But the way I'm going to look at today is using Kustomize, which is something everyone has. It's part of kubectl, and it's a way of doing what we're talking about here, setting a base set of resources, in this case, the upstream, and then applying some changes to those, mutating them. So you could do what I'm about to describe with Helm and OLM, and I'm hoping at some point in the future I can come up with some examples for that as well. But for now, I'm sticking with Kustomize because it doesn't require much in the way of dependencies. So for those who are not familiar with Kustomize, I'm not going to go into a deep dive. The demo repo is there for that, and the blog post goes through this in more detail. But essentially, you define a set of files and resources. You have a customization file that lists those resources, and inside there, you can specify any changes or mutations you want to make to them. So in this case, what we've got is an install file that defines the two operator versions we want to install. And if you notice, the CRDs here are separate. So in the upstream installation stuff from Strimzi, the CRDs are part of all these other resources. Here, as we said before, we need to keep them separate, and they need to match the most up-to-date version. So in this case, they will be the 044 CRDs. So in the example repo, I've got an installation script for adding new versions of Strimzi. And that will do those important checks to make sure that we've only ever got one version of the CRDs and they match the most up-to-date one. in that setup. So inside the individual versions themselves, there's the set of resources, service accounts, RBAC, the deployment for Strimzi itself, and then a set of patches and what we want to do to them. So if we have a look at the 0.43 version here, we can say we've got the resources, and then we've got this very useful tool that Kustomize gives you, which is called the name suffix. And all this does is it says, go through the list of resources above. Anytime you see a name, attach this string to the end of it. But the clever part that it does is that it then finds any references to that string and changes them as well. So if you've got a config map, it attaches this string to the end of it, and then anywhere that config map is referenced in the rest of it, it changes that name as well. So that allows us to isolate things quite easily. And then there's just a couple of changes you need to make to the RBAC and the deployment that aren't quite covered by the name suffix. So these patches are just saying, take this and layer it over the top of the upstream deployment. Most of these changes are stuff you have to do anyway in a production deployment. So here, for example, right at the top, we're telling Strimzi to be cluster scoped rather than namespace scoped. So that's a change it's just going to do anyway. And then we've got the custom resource selector. So here is the label that you need to look for. And then the leader election lease needs to be unique. So I've just made that unique in each case so that we can do high availability. And then in the RBAC settings, we're just changing the namespace, and we're just setting the subject name, because for some reason name suffix doesn't apply to the subject names in RBAC. But again, this will apply to all of the RBAC in that system. So once you've done this, your installation of this multi-Strimzi setup is one kubectl command. So we just install into this namespace. The -k command says, look for a Kustomize in this directory and do what it says. And so there's a hierarchy of Kustomize. The top level Kustomize defines all the resources below, and it cascades down. And that will just create the deployment we need. So if you deploy that, you will end up with something that looks a bit like this. So in this case, what we've got is one Strimzi namespace with 2 deployments in. You could do this in 2 separate deployments. It would just be a slightly different customized setup. You'd have to just change the names to be independent namespaces. We've got the 2 different sets of RBAC, and we've got the 1 set of CRDs from the most recent Strimzi. And then under here, we've got a set of Kafka deployments that are all set to the older version of Strimzi, in this case 0.43, because we want to upgrade to 0.44. So with this setup, we just change the label. So maybe we start with our own Canary instance. This is one we've got tests for ourselves, test a lot of scenarios. So we change that one over and we're happy with it. And then we can start to cascade up our risk register and start to roll things in turn as we're happy with them, check with client teams that everything's working. In staging, we've got some sample of production traffic, so we're happy with that. And then hopefully this would never happen, but we all know it will. Somewhere in production, something goes wrong and we've hit a configuration issue. Okay, these things happen, but now all we need to do is just switch the label back, and it will then, the old Strimzi will reconcile it, it'll switch it back to its configuration, which hopefully we know works because it was working before. We've switched it back, and then we can carry on. And what's good with this setup now as well is because it's just a label change, it's a lot easier to replicate this in our Canary dev cluster. I can go back to our dev cluster, switch that back to Strimzi 43, look at what's different in prod, set up a test thing, switch it back into the new one, test the upgrade before I then go back and try that. So it gives you that fine-grained control over what rolls and when. So at some point in the future, we've got onto this situation where everything in our Kafka clustering, and remember this includes Kafka Connect deployments, Mirror Maker, etc., are on the Strimzi 44. And so we're happy with it. Everyone will have their own procedures here to know when we're actually safe. Nothing needs to downgrade now. I'm happy. So what we can then do is just delete the 43 deployment. So you delete that file, that folder in the install files, the RBAC goes away, the CRDs are already pointed at the latest one. And then we redeploy this. So now we're down to a single Strimzi deployment. Everything's fine. We're happy with this. And then a new version of Strimzi is released. So then all we do is we just add the new 45 folder in. Obviously, we've got to update our CRDs because we need to be on the most recent version. We deploy that, and then we're off again, and we can do that as we did before. So there's a big red sign here because this is something you need to bear in mind, and bear in mind this is something you need to do with a modern Strimzi deployment as well, is that you need to always make sure that at no point in your install files are you deploying something that doesn't have the CRDs in. So you do not want to delete the CRDs, because if you do, the Kubernetes will merrily come along and garbage collect all of your Kafka infrastructure. This is something I probably don't need to tell seasoned veterans out there, but it can catch you out. You just need to build your CI tooling to make sure there is always a CRDs folder with the latest version in, so that your updating rather than deleting. So there is one final case I need to talk about, which is the CRD API version. So this is the actual version of the CRD resources themselves that needs to be updated. So the most recent example of this is Strimzi 0.22, which went from V1 Beta 1 to V1 Beta 2. And the special case here is that you just need to make sure that all of your resources are upgraded to the transition version. So in the old case, this will be, you need to upgrade everything to 0.22. You then need to remove 0.21, which was the one that supported only the old version. You've got rid of that now, that's not there. And nothing, no CR has got V1 Beta 1 that's running the 0.21. You then do the CRD upgrades, which Strimzi will do for you and explains how to do. So now you're in a situation where you're running the transition version, but you're running V1 Beta 2, and nothing is running V1 Beta 1. And only at that point install the CRDs for 0.23 if you were installing them together, because you need to make sure that nothing is running V1 Beta 1, because Strimzi's 0.23 only supports V1 Beta 2. Now that sounds complicated, but if you follow that pattern I was just talking about, whereby once you've moved everything onto the newest version, you get rid of the old version, you run any extra steps that Strimzi says you need to do at that version, like a CRD upgrade, and then you install the new version. If you follow that pattern, then you'll probably have this covered as well. But it's something to bear in mind, because at some point in the future, we're going to be moving to Strimzi, to the API version 1. So if you do something like this, it's just something to bear in mind. Okay, so wrapping up, I've said a lot of things here. Some key takeaways. If nothing else, the Strimzi Custom Resource Selector is a very powerful tool. Okay, so just it's good to know that it's there. It allows you to design a lot of these scenarios and situations you can use Strimzi with. You need to install, to get this to work, 2 adjacent Strimzi versions. And so you have to have one version only of the CRDs, and it has to be from the latest Strimzi version. Although I've noticed that it's called Strimzi here, which is very embarrassing. So sorry about that. Isolate the installation resources. That's the bit you just need to take some care about. You need to be able to deploy these 2 Strimzi resources. You can deploy them in separate namespaces. That covers you a lot, but there are some cluster scope things that you need to make sure have separate names, don't collide. So however you want to do that, I've given you an example with Customize. You could do it with Helm. You can do it with OLM. And then only installing 2 versions of Strimzi that are next to each other. So that's the supported setup. But once you have this situation and they have their own Strimzi custom resource selector, you are able to do upgrades by just handing CRs off between Strimzi instances. And rollbacks are just a simple label change. So that gives you a lot of power as an infrastructure team to be able to fine-grain pick which of these things you want to upgrade and when. You can talk to your upstream teams. You can say to them, look, we're going to roll at this time on this place and you're on this schedule. Gives everybody a bit of breathing space and to know what's coming down the pipe. Take care with your CRD upgrades. I know I've labored that point, but it's important. You need to make sure they're never deleted and they're only updated. And also when you have these API upgrades, there's just a little bit of procedure there to make sure that you're doing the steps that Strimzi lays out, but just watch out for that. The final point is that this resource selector, it's not just about upgrades. It's any 2 instances of Strimzi. So here you can imagine within the same version, I've said here you can only have 2 adjacent versions, but within the same version, you can deploy multiple copies of that. So your selector could, in this case, we put it down as Strimzi 0.43, but it could be Strimzi 0.43a, and then your next one could be Strimzi 0.43b and c. And each of those could have a different configuration. You could have for your very most gold-plated, risky clusters, you could have your own Strimzi deployment just for those. So you can use it to load balance if you have a heck of a lot of Kafka clusters. Maybe you want to load balance between Strimzis. Again, you can do that here with this tool. So it does unlock a lot of more advanced deployment options. So I've said a lot of words. This is a very high-level description. There is a much more low-level walkthrough in the blog, so please give that a read. There's a demo repo with some example code in. PRs are open. Anybody try that out and have issues, I'll be very grateful. I think we've got some time for questions now, but as I said before, I'm on the upstream Slack or in the chat if you need me. Thanks very much.
Thank you very much, Tom. It was a great session. So we have a couple of questions here. Let me start with the first one. So the first one says, what will be the best way to handle Strimzi updates if Strimzi is managed by another team? we have a setup where the operators are managed by our infrastructure team, and we are managing the CRDs. They will communicate when they will upgrade Strimzi. Should we upgrade the CRDs beforehand?
So they should be upgraded beforehand, but Strimzi should be upgraded very soon after that. So you want to keep those two things. If you're only installing one version, you want to keep those two things in lockstep as close as possible. It's quite a strange situation having somebody managing the CRDs and somebody else managing the operator, but I've seen stranger setups. But it would be better if the two things were managed together. And again, with this setup, so if you had a setup like this would be just a different thing that they were deploying, but here you can see how the CRD management is key. So you wouldn't want those two things managed by separate teams, but you should upgrade Strimzi as soon as possible after upgrading the CRDs.
Yeah, there is a follow-up question, I guess, from Jakub, if they are really managing CRDs or the CRs, which are two different things,
yes.
right? That could be
people get those mixed up more often than you
yeah.
would think. It's very important to know that.
And yeah, let's move on with another question. If maybe we will get this cleared, if they are CRDs or CRs. The next question is, can we use your procedure pattern with GitOps?
Yes, I would think so. I say off the top of my head. The customize setup here is something that you could have a GitHub action apply. So you define, and in fact, if you look at the example repo that I've got, it's a set of YAML files with customized mutations applied to them. You do all that through PR check-ins. Because you will probably want to customize your Strimzi setup, and you would do it in there. You'd have your base resources, and then you'd mutate them. And so then you could have a GitHub action or your CI just to run that kubectl apply section through whatever system you want to use to do it. There are many out there. You have Argo, you could have all these different systems to deploy that. But all the base files, customize itself is very well suited to it's just being applied through kubectl. So anything that talks kubectl can take these base files and apply them.
Yes, right. So thank you very much, Tom. I can't see any more questions here in the chat or in the Q&A. As already mentioned by Tom, is available on the Strimzi Slack channel. So if you have any other question coming later, or you want to engage with Tom to get more details about this session, feel free to jump into Slack and tagging him. He will be really happy to answer all your questions. So again, thank you very much, Tom. Thank you for your session. It was great.
Thanks very much, folks.